picture the deadliest thing in the ocean. Now picture it dead. Not eaten, not outcompeted, not starved out by something with bigger teeth. Murdered. The first real monster the seas ever built. A fish wearing a suit of armored bone, with a mouth that could shear a shark clean in half. Something wiped its entire kind off the planet forever. But the prime suspect in this case isn't a bigger predator, and it isn't a rock falling out of the sky. It's a tree. This is a cold case, and the killer had roots. Let's start with the body, because every good cold case starts with the body. In 1867, an amateur fossil hunter named J. Terrell was picking his way along the shale cliffs above Lake Erie, near a little Ohio town called Sheffield Lake, when he found something jutting out of the black rock. It was bone. Big, thick, armored bone, plates of it, locked together like the panels of a tank. Terrell had no idea what he was looking at, so he gave it the only name that fit: the terrible fish. Decades later, scientists gave it a proper name, Dunkleosteus terrelli, honoring a museum curator named David Dunkel and old J. Terrell himself. And in 2020, Ohio liked it enough to make Dunkleosteus its official state fossil fish. Not bad for a monster nobody has seen alive in over 350 million years. Because that is exactly what this thing was. Roll the clock back to the Devonian period, an age so completely dominated by fish that paleontologists just call it the age of fishes, and Dunkleosteus sat at the very top of it. It belonged to a group called the Arthrodires, an armoured kind of fish known as placoderms, and it was the first animal on Earth you could honestly call a superpredator. The first backboned animal to ever get big enough and mean enough to rule an entire ocean. Everything else in that warm Devonian sea was prey, and on some level it knew it. And it ate well. Sharks already prowled the Devonian oceans, and Dunkleosteus almost certainly ate them. It ate other armoured fish. It ate the coiled, shelled ammonoids drifting through the water column. Some of the fossils even carry bite marks that match Dunkleosteus itself, which hints that when times got lean, it was perfectly willing to eat its own kind. Nothing in that water was truly off the menu. This was an animal that treated the entire ocean as an all-you-can-eat buffet, with itself as the guest of honour. Now here is the first strange detail in our case file. Dunkleosteus had no teeth. Not one. Where you would expect a mouth crowded with daggers, it had something worse. The front edges of its own jaw bones had grown out into two long bony blades, and every time the mouth closed, those blades slid past each other and ground themselves sharp. Self-sharpening bone. The animal swam around with a built-in pair of guillotine shears in its face, and they only got keener with every bite. You know how a great white constantly loses teeth and grows replacements. Dunkleosteus never had that problem. It just kept honing the same murder weapon its entire life. And this is where I have to ruin a childhood memory for some of you. If you grew up on nature documentaries, you probably picture Dunkleosteus as a 30-foot leviathan, a submarine with a face, 6 to 10 meters of nightmare cruising the deep. Let that image go. In 2023, a researcher named Russell Engelman at Case Western scrutinized the actual fossils with fresh, skeptical eyes, and there is a real problem hiding in them. We almost only ever find the armored head and shoulder shield. The rest of the body was cartilage, and cartilage does not fossilize. So for a century, people basically guessed at the body length. And they guessed enormous. Engelman used a smarter method, measuring the eye socket and gill cover region and scaling it against the proportions of living fish, and the number came back a whole lot smaller. A typical adult, more like 3.4 meters, so roughly 11 feet. The largest individual we have, solid evidence for, maybe 4.1 meters, call it 13.5 feet. So it was not a bus with fins. Shorter, stockier, built like a wrecking ball with the rough body shape of a tuna, all muscle and momentum and bad intentions. Before you feel too relieved, understand that even at that size it was probably still the single largest animal on the entire planet at the time, and that mouth did not shrink to match, even on the downsized body. The gape came out roughly twice the width of a great white shark's. A tuna the size of a small car, wearing the doubled grin of a great white forged out of self-sharpening bone. That is our victim. The new size is still argued about, by the way. Some workers push back and estimate closer to 5 meters, around 16 feet, but nobody serious is arguing it back up to the old sea monster numbers, because the size was never really the scary part. The engineering was. In 2007, two scientists, Philip Anderson and Mark Westneat, built a working mechanical model of that skull, and what they found is honestly beautiful in a horrifying way. The whole head operated as a 4-bar linkage, a chain of moving parts where the skull, the jaw and the muscles all pull together in one coordinated snap, 4 separate joints firing in sequence. It let the animal do 2 things that normally cancel each other out. It could yank its mouth open fast enough to suck prey in like a vacuum, and it could clamp down with enough force to crush armor. Most predators have to pick one or the other. This one cheated and took both. How fast are we talking? The model says Dunkleosteus could throw its mouth to full gape in about 20 milliseconds, 20 thousandths of a second. Faster than you can blink, faster than most fish could even register that the patch of water in front of them had suddenly become a mouth. A full bite cycle, open and snap shut, ran maybe 50 to 60 milliseconds, and the force behind that snap came in on the order of 4,000 newtons out at the fang tips and higher than 5,000 back at the rear blades where the leverage was best, at least for a large individual. That places it among the strongest bites ever measured in any fish, living or extinct. Now, you may have heard somebody claim that Dunkleosteus outbit Tyrannosaurus rex. Throw that one out. It is a zombie fact that refuses to die, and it is simply wrong. Built on the old oversized body, the truth does not need the hype. A tuna-shaped tank that opens its mouth in 20 milliseconds and closes it with self-sharpening shears is plenty frightening on its own merits. So there's our victim, the perfect killer, the apex of that whole age of fishes, along with the entire armored dynasty it belonged to. Placoderms had ruled the water for tens of millions of years. Then, in what amounts to a geological blink, every last one of them was gone. It was not reduced or clinging on in some quiet corner of the sea. It was gone, right down to the final individual, 0 survivors. The most successful body plan in the ocean, erased. So what does it take to murder a perfect killer? To answer that, we have to visit the crime scene. And this is where the case gets strange, because there are 2 of them. The late Devonian did not die once, it died twice. People talk about the late Devonian extinction like it was a single event, but when you read the rock closely, you find 2 separate killing pulses, spaced roughly 13 million years apart. The first is called the Kelwasser event, and it struck around 372 to 374 million years ago, at the boundary geologists label the Frasnian Femenian. The second is the Hangenberg event, and it hit at the very end of the Devonian, roughly 359 million years ago, right where the Devonian hands off to the Carboniferous, 2 crime scenes. And both of them left the exact same calling card, smeared across the whole planet. You can find these dark bands on multiple continents, in rock that was once seabed from Europe to North Africa, all recording the same disaster at roughly the same moment, a layer of black shale. Dark, oily, oxygen-starved mud, the kind of sediment that only forms at the bottom of a dead, suffocated sea. Hold on to that black shale. It comes back at the end of this story in a way you will not see coming. Now here is where almost every retelling of this case gets it wrong, including versions you have probably watched. People love to say the placoderms, Dunkleosteus and its whole armored clan, were wiped out in that first pulse, the Kelwasser. It is a tidy story. It is also false. The armored fish survived the first hit. They took casualties, absolutely, but they were still swimming afterward. What truly finished them was the second pulse, the Hangenberg, at the bitter end of the period, and for a long time, nobody even grasped how enormous that second event was. In 2010, 2 paleontologists, Lauren Sallin and Michael Coates, published a study that reframed the entire thing. They showed the Hangenberg was a previously unrecognized bottleneck in the history of vertebrate life. In plain language, it was a moment when the whole family tree of backboned animals got choked down to a handful of surviving twigs. The losses were savage. The Hangenberg knocked out close to a third of all vertebrate genera, against roughly a fifth in the earlier Kelwasser. That second event was the real slaughter, and it did not simply kill things, it reshuffled who was in charge. Coates described it in a way that stuck with me. The roles in the ecosystem survive, but the players change. The ocean still needed a top predator, still needed a fast open water hunter, still needed something grubbing along the bottom. But after the Hangenberg, completely different kinds of fish stepped into those empty roles. Salon put it even sharper. She said the age of fishes carried on, but it was the wrong kind of fish that inherited the future. Nearly everything that dominated the Devonian died, and the meek little survivors that nobody would have bet a nickel on were the ones that rebuilt the world. We will circle back to why that matters to you personally, because it does. First, we have to solve the murder. Who wipes out the reigning champions of the ocean twice in two pulses 13 million years apart and leaves nothing behind but black mud? When you have a mass extinction, the usual suspects line up quickly. An asteroid, like the one that finished the dinosaurs. Colossal volcanic eruptions choking the sky. A sudden crash in sea level. Detectives chased all of those here, and we will get to their alibis. But the late Devonian has a problem that none of the obvious suspects explains cleanly. These killings were weirdly picky. They hammered marine life, especially in the warm, shallow seas that flooded across the continents. They gutted reefs and shallow water animals, and they kept leaving that same signature black shale again and again on continent after continent, as if the oceans themselves kept running out of air. Whatever did this was not just dropping a rock into the water, it was rewriting the chemistry of the entire planet's oceans, slowly, from the edges inward. The timing was the strangest clue of all. Both killing pulses lined up with those worldwide black shales, and both bit hardest in the shallow sunlit seas closest to the continents, the exact waters you would expect to suffer first if something on the land was bleeding into the ocean. The evidence was not pointing out toward the stars, toward some cosmic disaster. It was pointing straight back at the shoreline. So the real question the detectives had to ask was this: what changed on Earth during the Devonian that had the reach to strangle oceans all over the globe? The answer was happening on dry land, and it was green. When the Devonian began, the land was essentially naked. A few low, mossy, ankle-high plants clung to the muddy edges of rivers, and that was about it. No forests, no real soil, nothing you would recognize as a landscape. If you time travel to the early Devonian, the continents would look like an alien world, all bare rock and mud and green scum. But over the long stretch of deep time that followed, plants pulled off something they had never managed before. They stood up. They grew wood, and they grew tall, and most important, for our purposes, they grew roots, deep ones. This is the stretch of time when trees are invented, and one tree in particular is sitting right at the top of our suspect list. Its name is Archaeopteris. Try not to confuse it with Archaeopteryx, the feathery little dinosaur bird, a totally different creature with an annoyingly similar name. Archaeopteris was a progymnosperm, a kind of proto-tree, and it shot up to nearly 100 feet tall. But its height is not what makes it a killer. What earns it top billing on our suspect list is that Archaeopteris was, functionally, the first modern tree. This was the first plant to assemble the whole package in one organism. Flat green leaves to soak up sunlight, real wood in the trunk, and a root system that was deep and laterally spreading and complex all at the same time. Before this, plant roots were shallow and simple little anchors. Archaeopteris drove its roots down and out through the ground like nothing that had come before. That specific combination, leaves and wood and deep branching roots, is the basic blueprint for essentially every forest that has existed since. It appeared in the Devonian, and this planet was never the same again. We can go stand in one of these first forests because we found one. In 2019, researchers led by William Stein and Christopher Berry described the oldest known forest on Earth, preserved in an old quarry near Cairo, New York. It is about 386 million years old, and what stopped everyone cold was the ground itself, fossilized into that ancient soil were the root systems of Archaeopteris. splaying out something like 18 feet from where each trunk once stood, with individual root networks traced across more than 35 feet of quarry floor. That is a shockingly, unnervingly modern root system. Stein called the whole thing strikingly modern, and said the way it all came together looked, in his own words, like a miracle. A fully modern forest floor, hundreds of millions of years before it had any right to exist. To put that in perspective, this root system predates the first dinosaurs by well over 100 million years. It predates almost everything you picture when you think of the word ancient. And yet, if you brushed the dirt off it, you would swear it belonged to a tree growing in a park down the street. That is how far ahead of its moment Archaeopteris was. It engineered the modern forest floor while the rest of the planet was still working out how to grow a decent leaf. I do have to flag one thing here, because people mix this up constantly. There is another famous ancient forest site right in the same neighborhood, at a place called Gilboa, with those iconic fossilized tree stumps you may have seen. But the Gilboa trees are a different group, cladoxylopsids, and their roots were shallow and short-lived. Perfectly nice trees, not our killer. It is the Cairo forest with those deep, sprawling Archaeopteris roots that shows us the actual weapon being forged. Because deep roots do something drastic to a planet, and this is the moment our tree stops being pleasant scenery and becomes a murderer holding two very different weapons. Weapon number 1. Poison. When Archaeopteris drove those deep roots down into bare Devonian bedrock, it did something no plant had ever done at that scale. It broke the ground open. Roots wedge into cracks, they pry rock apart, they leak acids, and they trap moisture against stone. Do that across whole continents for millions of years, and you do not just get roots sitting in dirt. You manufacture the dirt. You build the first true deep soils the planet had ever had. Geologists call that soil-making process pedogenesis, and the Devonian is when it really roars to life. This is the core of what is called the Devonian plant hypothesis, first laid out in the 1990s by Thomas Algeo and his colleagues, who argued that this entire marine catastrophe was, quite literally, rooted in the rise of land plants. So why did making soil turn out to be lethal thousands of miles away, out in the open ocean? Because deep roots and fresh soil massively sped up something called chemical weathering, the slow dissolving of rock. And rock, as it dissolves, releases nutrients. In particular, it releases phosphorus. Phosphorus is fertilizer. Rivers scooped up all that freshly liberated phosphorus and flushed it downstream, off the continents and into the shallow seas ringing them. Now dump a continent's worth of fertilizer into a warm, shallow sea, and you get precisely what you would get by dumping fertilizer into a farm pond today: an explosion. Algae bloom across the surface in vast green and red mats. It looks like life winning. It is the opposite. There is a bitter joke buried in that. The forests were the greatest surge of new life the land had ever witnessed, and downstream, that very same surge was quietly manufacturing death. More plants meant more soil. More soil meant more fertilizer bleeding into the sea. And more fertilizer meant an ocean slowly choking on its own abundance, because all of that algae dies, and when it dies, it sinks, and it rots, and the rotting is carried out by bacteria that breathe oxygen, the very same oxygen dissolved in the water that every fish and every reef animal needs to stay alive. Bloom, die, rot, repeat, at continental scale, and those bacteria strip the oxygen straight out of the water. The technical word is eutrophication, but the honest word is suffocation. Whole regions of the seafloor went anoxic, meaning no oxygen at all. And in some places, it turned nastier still. The water went eucynate, filling up with hydrogen sulfide, the rotten egg poison gas. Imagine an ocean where the deep water is a still, black, poisonous soup that stinks of rotten eggs and kills anything unlucky enough to swim into it. That soup, settling and hardening over millions of years, becomes the black shale. Remember the black shale? Every one of those dark layers at our crime scenes is a photograph of a sea that the forest helped strangle. That is weapon 1. The forest fertilized the ocean to death. If you're enjoying this, hit subscribe. There's a lot more ahead, because we have only found one of the murder weapons so far, and the second one does the exact opposite of the first. Weapon number 2. cold. This is the twist that most versions of this story skip entirely, and it happens to be the best part. The same forests that were fertilizing the oceans to death were also quietly rewriting the sky. Trees are built mostly out of carbon, and they get that carbon by pulling carbon dioxide out of the air. A planet that suddenly sprouts its first genuine forests is a planet that suddenly has billions of tons of carbon locked away in wood instead of drifting around as greenhouse gas. And the effect stacks. Remember all that dead algae and plant matter getting buried in the black shale? That is carbon too. Carbon getting shoved down into the rock and pulled out of the atmosphere for good. Between the wood standing on land and the black muck piling up on the sea floor, the Devonian world was scrubbing carbon dioxide out of its own air on a staggering scale. And unlike a wildfire, which hands its carbon back to the sky within a season, this was a one-way trip. The cooling had nothing to reverse it. The forest was not gently nudging the planet's thermostat. It was tearing it off the wall. The Devonian had opened as a hothouse with carbon dioxide levels far higher than anything today. But as the forest spread, those levels came crashing down towards something close to modern values. And when you strip the greenhouse gas out of the sky, the planet does exactly what you would expect. It cools. It cooled hard enough that the late Devonian tipped over into a brief ice age, with glaciers creeping outward near the poles. So the same green invasion was striking the ocean with two opposite weapons at once. On one hand, nutrients pouring off the land and suffocating the water. On the other hand, carbon vanishing from the air and freezing the world. Fire and ice, except here, the fire was fertilizer and the ice was painfully real. That second weapon also solved a serious headache for the detectives. The trouble was tempo. The rise of the forests was slow, playing out gradually across millions of years. But the killing pulses, the Kelwasser and the Hangenberg, were sharp and sudden in geological terms. How does a slow, gradual change on land trigger a fast, brutal catastrophe in the sea? A refined version of the hypothesis, published by Algeo and colleagues around 2001, cracked that open. The forests set the stage slowly, drawing carbon down over ages, but the actual triggers, the exact moments the sea flipped over, were transient pulses of cooling. Short, sharp, cold snaps that shoved the shallow shelf seas over the edge into anoxia, then eased off, then struck again. Slow setup, sudden execution. The forest loaded the gun across millions of years, and the cold pulses squeezed the trigger. Two weapons, one patient and one quick, working the same victim. So let's walk back to our victim, Dunkleosteus, and to the rock we dug it out of. Because the murder weapon left a fingerprint, and the body was buried right inside it. The most famous Dunkleosteus fossils on Earth, the ones sitting in museums, the ones you have almost certainly seen, come from a rock formation called the Cleveland Shale in Ohio. And what kind of rock is the Cleveland Shale? It is black shale, the hardened mud of a dead, oxygen-starved sea. The perfect killer is entombed in the exact sediment of the exact conditions that murdered its whole lineage. The victim is lying inside the poison that did it in, but it gets better, or worse, depending on how attached you've gotten to our fish. In that same Cleveland Shale, over in Kentucky, geologists found something that has absolutely no business being there. A boulder. A single slab of granite weighing around 3 tons, sitting in the middle of sediment made of the softest, finest particles imaginable. There is only one way a 3-ton rock ends up floating out into the deep ocean before dropping into fine seafloor mud. Ice. The boulder was frozen into a glacier or an iceberg, rafted far out to sea, and when the ice finally melted, the rock plunged to the bottom and buried itself in the muck. Geologists call it a dropstone, and it is a physical fingerprint of that Devonian glaciation, the cold weapon, sitting in the very same rock layer that entombs the predator. Think about what that means. The armored king of the seas, the poison that choked the water, and the ice that froze the world, all pressed together into a single slab of black stone. The killer was buried inside the evidence of what killed it. If this were a detective novel, your editor would tell you it was too on the nose. Now I owe you some honesty, because a good detective does not pretend a case is closed when it isn't. The tree did it. That is the leading theory, and it is a strong one, but it is a prime suspect, not a courtroom conviction, and there are other names still up on the board. The end of the Devonian is one of the most fiercely argued over extinctions in all of Earth's history. Some researchers point instead at a straightforward crash in sea level as the growing glaciers locked up the world's water. Others blame a crisis in ocean chemistry that made it brutally hard for animals to build shells and skeletons. Some argue for enormous volcanic eruptions poisoning the environment, and there is even evidence of mercury contamination, spikes of the metal that giant volcanoes can spew, showing up in rocks from exactly this time. And out on the fringe, a few scientists have floated some wild ideas, like a nearby star exploding as a supernova and shredding the planet's protective ozone, or a good old-fashioned asteroid strike. There is also a strange wrinkle worth mentioning. By the late Devonian, oxygen in the atmosphere had climbed high enough to fuel wildfires, so patches of those young forests were literally burning down. This was never one clean murder with one obvious weapon. It was a whole planet convulsing through several tangled changes at once. But nearly every one of those changes traces back, in one way or another, to the same green takeover creeping across the continents. The forest may have had accomplices. It is still the one caught holding the smoking gun. And now for the part that flips this entire story on its head, because the murder of the perfect killer is the reason you are here to hear about it. Follow the thread with me. When the Hangenberg squeezed vertebrate life down through that narrow bottleneck, the placoderms did not make it through. The whole armored dynasty, Dunkleosteus and every armored cousin it had, went extinct and never came back, not once, not anywhere. That is a hard, final ending for our monster. But something had to rise up and fill the emptied ocean it left behind, and two big groups of fish were waiting for the vacancy. The lobe-finned fishes, with their thick, muscular, limb-like fins, and the ray-finned fishes with their thin, fanned, spiny fins. Before the extinction, the lobe fins were doing just fine, thanks. After it, the ray fins exploded, seized the throne, and never handed it back. Today, ray-finned fishes are the single most successful group of backboned animals on the planet, something like 30,000 species. Nearly every fish you can name, the salmon, the tuna, the goldfish, the fillet on your dinner plate, is a ray fin. The irony there is almost too clean. The armored fish spent the entire Devonian as the undisputed heavyweight champion of the sea. Meanwhile, the ray fins spent that same era as small, forgettable also-rans, the sort of fish the champion swallowed without noticing. And it was the also-rans who walked off with the whole planet. Being the best adapted animal of your age, it turns out, is a very different thing from surviving the moment your age ends. That entire branch of life got its opening because a suffocating, freezing ocean swept the old champions out of the way. And it reaches further than fish. That same bottleneck, that same great clearing at the close of the Devonian, sits right beside one of the most important doorways in the whole history of animal life. The lobe-finned fishes that survived included the ancestors of the very first four-legged animals, the first tetrapods, the pioneers that would eventually haul themselves out of the water and onto the land, and the thin, strange stretch of time right after the Hangenberg, when the world was still recovering and life was scarce and hard to find in the fossil record, has its own name. Paleontologists call it Romer's Gap, a window of a few million years where the fossil record of four-limbed animals goes almost eerily quiet, as though evolution itself needed time alone in a dark room to recover from whatever it had just survived. When the record finally picks back up, the descendants of those survivors are crawling out onto dry land in earnest. That gap sits directly on the road that leads out of the water, up onto the shore and onward to amphibians, to reptiles, to mammals, and eventually to a curious primate who would one day pry an armored fish out of an Ohio cliff and wonder what on earth had killed it. The perfect killer had to die so that our branch could inherit both the water and the land. If Dunkleosteus and its armored kind had kept their grip on the oceans, the entire story of vertebrate life, which is to say, our story, might have unfolded completely differently, or never unfolded at all. So the next time somebody tells you a tree is just a tree, think about this case. The most fearsome predator the early oceans ever produced A tuna-shaped tank with self-sharpening jaws that snapped open in 20 milliseconds was brought down not by something bigger and meaner, but by the quiet, patient spread of the first forests. Killed twice over, by poison and by cold, then buried in the black stone of the very sea it helped suffocate, it is a reminder that on this planet, everything is wired to everything else. And the smallest change in one place, given enough deep time, can quietly rewrite the entire world somewhere far away. Life does not merely live on the Earth. It reaches down, grabs the planet by its chemistry, and remakes it. Sometimes that remaking grows a forest. Sometimes it murders a king. This channel is full of deep-time cold cases, exactly like this one. Mysteries older than the first dinosaurs, with the evidence still lying in the rock. If you want the next one, subscribe, and I will see you back here in the deep past.